Hey everyone, and a massive welcome to all of our 12th grade chemistry students tuning in. If you're gearing up for those public exams, well, you're in exactly the right place. I am super excited to welcome you to this special study guide explainer. Today, we're going to master a seriously high-yield exam topic. We're looking at 12th Chemistry, Unit 7. Specifically, we're zooming right in on Section 7.9. That's the factors affecting reaction rate, the whole fascinating collision theory, and exactly how catalysts work. This single topic, it is literally a gold mine for marks in your public exam. By the time we wrap up this explainer, you're going to have it completely locked down, for sure.
Okay, let's dive right into this agenda. First up, a quick Unit 7 introduction. Then we'll break down the 6 key factors, look at some public exam questions, check out a visual summary, and finally, wrap up with your quiz and test prep.
Section 1, Unit 7, Introduction. Let's kick things off right now. Grab your Toot study guides, get them ready, because we're doing a methodical, line-by-line breakdown of Section 7.9.
Take a look at this full PDF of your Toot guide. Specifically, we are on page 67 EM. Now, I really cannot stress this enough. This single page is basically your master key. If you look at the top there, it holds the exact answers to key 2-mark book-back questions. We're talking question 8, question 21, and question 22. It lays out exactly how a catalyst, concentration, and the nature of reactants influence the speed of a chemical reaction. The whole page is just packed with answers, so let's unlock them.
Moving right along to Section 2, the 6 key factors. We're going to read straight from the guide here, so get ready to memorize the exact sequence of these 6 factors. All right, here is the exact order, straight from the table in that TOT guide. 1. Nature of the reactant. 2. State of the reactant. 3. Concentration. 4. Surface area. 5. Temperature. And 6. Presence of a catalyst. Honestly, fixing this exact order in your mind is absolutely crucial for the public exam. Just say them with me in your head and lock that order in. Got it? Let's keep moving.
Let's read the first factor line by line from the guide. Nature of the reactant. The guide gives us this really brilliant comparison. The reaction rate between potassium permanganate and ferrous ammonium sulfate, or FAS for short, is incredibly fast. But if you take that exact same potassium permanganate and, say, react it with oxalic acid, the reaction is agonizingly slow. I mean, even if you heat it up to 60 degrees Celsius. This just proves that the intrinsic, fundamental nature of the chemicals you start with changes absolutely everything about how fast they react. It's wild.
Now, what's really interesting about this next slide is how simple but totally powerful the second factor is, the physical state of the reactant. Check out the rate order here. Gas reacts faster than liquid, and liquid reacts way faster than solid. The guide shows us that gaseous iodine reacts much, much faster than solid iodine. Same thing goes for lead nitrate. Using liquid potassium iodide gives you a way faster reaction than using the solid version. Basically, the freer the molecules are to move around, the faster the reaction. Makes sense, right? Okay, let's group factors 3, 4, and 5 together, mostly because they all share the exact same underlying logic. If you increase the concentration, or the surface area, or the temperature, guess what? The rate of the reaction increases. Why? Reading right from the guide here, the reason is collision theory. Ramping up any of these 3 things leads to more molecular collisions per liter per second. And more collisions literally means a faster reaction. It's kind of like a giant game of bumper cars. It really is just a numbers game. And this brilliantly illustrates our 6th and final factor, the presence of a catalyst. Look at the theoretical mechanism and the physical evidence we have here. The guide explains that a catalyst actually lowers the energy of activation. Over in the physical test tubes, we've got a mix of oxalic acid, potassium permanganate, and dilute sulfuric acid. In test tube A, we drop in a manganese sulfate catalyst, and boom, almost like magic, the pink color just disappears instantly. Meanwhile, in test tube B, no catalyst, the pink color just stubbornly stays there. The catalyst basically provided a shortcut, an alternate pathway with a much lower energy barrier, which drastically sped up the reaction. Section 3, Public Exam Questions. All right, this is the most crucial part. We're going to apply everything we just read directly to previous year questions, or PYQs. Let's turn that knowledge into marks. Check out this PYQ from the June 2020 public exam. It's directly referenced in your Toot guide, by the way. The question asks, powdered calcium carbonate reacts much faster with dilute HCl than with the same mass of calcium carbonate as marble. Give reason. So I want you to just pause for a second. Think about it. Which of our 6 factors perfectly applies here? Well, if you guessed factor 4, you hit the nail on the head. The exact answer is all about the surface area effect. You see, powdered calcium carbonate has a massively higher surface area compared to just a solid, chunky block of marble. And as we just learned from collision theory, that increased surface area leads to way more molecular collisions per liter per second. So the reaction rate is directly proportional to the surface area. It's simple, it's logical, and it is a guaranteed full marks answer. Let's tackle another one. Shift your focus to the bottom left of page 67 EM. This is a 1-mark question from the March 2023 exam. It also popped up in NEAT. And bonus, it's your book back question number 8. It asks, the addition of a catalyst during a chemical reaction alters which of the following quantities? Is it A, enthalpy, B, activation energy, C, entropy, or D, internal energy? So the crucial point here is remembering that potential energy graph we were looking at just a moment ago. The correct answer is B, activation energy. Catalysts don't mess with the starting energy, and they definitely don't change the ending energy. They purely work by lowering that middle activation energy barrier, making it, just so much easier for the reactants to actually turn into products. Moving into section 4, our visual summary, let's lock in everything you've learned today through a comprehensive visual dashboard. Let's move to this slide and see how this all builds together. Here is your kinetics control panel. It's essentially a perfect visual map of page 67 EM. You can clearly see the nature of reactants, the physical states from solid to gas, plus concentration, surface area, and temperature, all of them feeding right into that central collision node. And then right at the bottom, we have the catalyst engine, complete with that activation energy graph and the exact test tube color change from the PYQ we analyzed. Honestly, try to take a mental snapshot of this complete image. When you're sitting in that exam hall, this is exactly the map you want to recall. Section 5, quiz and test prep. All right, pay close attention here. These are the final, actionable study tasks required for your upcoming test. First up is your 10-question contact quiz. We're actually pulling question 1 directly from the bottom right of that 67 EM PDF, which, by the way, is also your book back question number 10. It's a classic formula-based question. It says, in a reversible reaction, the enthalpy change and the activation energy in the forward direction are respectively minus X kilojoules per mole and Y kilojoules per mole. Therefore, the energy of activation in the backward direction is what? As the guide shows us, the quick memorization shortcut answer, to save you precious exam time, is simply open bracket, X plus Y, close bracket, kilojoules per mole. Why? Well, because you have to account for both that forward enthalpy change and overcome the original activation barrier to go backwards. Make sure you mark that down. Okay, here are your clear homework action items for tonight. First, finish up the rest of that 10-question quiz. Second, and please listen, this is highly important, prepare for tomorrow's test. The questions for tomorrow's test are going to be drawn specifically from section 6.9 in your TOOT section-wise worksheet. Please ensure you are rigorously studying those section 6.9 questions tonight so you can absolutely ace that test tomorrow. You've got this. We're going to wrap up this explainer with that thought. You see, mastering chemical kinetics, it isn't just about memorizing exam rules. It's really about grasping the invisible molecular collisions that are quite literally driving the universe. Next time you make tea, just ask yourself, why does crushing a sugar cube make it dissolve faster? And more importantly, what other invisible collisions are shaping the world around you right now? Good luck on your tests and public exams, guys, and keep questioning everything.